DHCP version 4 assigns IPv4 addresses dynamically. However, in a small branch or Soho location, a router can be configured to provide DHCP version 4 services without the need for a dedicated server. Cisco iOS feature called EasyIP offers optional full-featured DHCP version 4 server, which includes 3 different mechanisms for IPv4 address assignment. The first one is manual allocation, in which the administrator assigns a pre-allocated IPv4 address to the client, and the DHCP version 4 communicates only IPv4 addresses to the device. The second one is automatic allocation, where DHCP version 4 automatically assigns a static IPv4 address permanently to a device, selecting the address from a pool of available addresses. The third one is dynamic allocation, when DHCP version 4 dynamically assigns or leases an IPv4 address from a pool of addresses for limited periods of time, or until the client no longer needs the address, but the last one is the most frequently used. In the image, we can see a DHCP version 4 works in a client-server architecture. So when a client communicates with a DHCP version 4 server, the server then assigns or leases an IPv4 address to that client. The client connects to the network with a leased address until it expires. When the client PC disconnects or turns off, the leased address is released. When the client boots, it begins a 4-step process. First, as shown in the picture, the client starts the process with a broadcast called DHCP discovery message with its own MAC address to discover available DHCP version 4 servers. At the boot up, the client has no valid IPv4 information, so it uses layer 2 and 3 broadcast addresses to communicate with the server. When the server receives the DHCP discovery message, it reserves an IP to lease to the client and creates an ARP entry consisting of the MAC address of the requesting client and the leased address. Then the DHCP version 4 server sends the binding DHCP offer message as unicast to the client using its layer 2 MAC address. When the client receives the DHCP offer from the server, it sends back a DHCP request, which is used for lease origination or renewal. When it's a lease origination, the DHCP request works as an acceptance notice to the selected servers, declining other servers' offers. In multiple DHCP version 4 servers, the DHCP request message is sent as a broadcast to inform other servers about the accepted offer. The server verifies the lease information by returning a DHCP acknowledgement. The same thing happens when a lease renewal occurs. This happens when the lease has expired and the process for requesting a new IP starts again. Now we will see the message format. The messages are encapsulated in a UDP transport protocol, and the messages sent from the DHCP client use UDP source port 68 and destination port 67. DHCP version 4 messages sent from the server to the client have source port 67 and destination 68. The operation code specifies the general type of message. 1 indicates a request message and 2 a reply message. The hardware type are the same used in ARP messages. 1 is for Ethernet, 15 for frame relay, and 20 for serial lines. In the hardware address len, the number of hops is set to 0 by client before transmitting a request. The transaction identifier is used by the client to match the request to replies received from the server. The seconds defines the number of seconds elapsed since the client began attempting to acquire or renew a lease. Is used by servers to prioritize replies when there are a lot of clients. Flags are used by the client that doesn't know its address when it sends a request. Only one of the 16 bits is used for the broadcast flag. One tells the server or relay agent receiving the request that the reply should be sent as broadcast. The client ID address is used by the client during lease renewal, so the client puts his own address in this field only if it has a valid address in the bound state. Then there is the client address and the server address. The gateway IP address which routes messages when the DHCP version 4 relay agents are involved. Client hardware address includes the physical layer of the client. Server name is used by a server sending the DHCP offer or DHCP acknowledgement messages, or optionally its name. The boot file is optionally used by the client to request particular boot file. At last, DHCP options include several parameters required for basic operation. Now we are going to talk about the DHCP version 4 Discover and Offer messages. The DHCP Discover message is sent when the client device boots or senses an active network connection. At this point, the client doesn't know the subnet to which it belongs, so the message is a broadcast. The source IPv4 address is 0000, while the server releases one address for the client. The DHCP offer from the server contains the new address for the client. It can be configured to provide other information such as lease renewal time and DNS address. The server responds, assigning values to the subnet mask. When IP assigning is complete, it sends an acknowledgement message to complete the process. A router can be configured to act as a server as shown in the image. First, we will exclude IPv4 addresses using the command exclude address from the address pool. Addresses can be excluded in a range from low to high. Then we configure the address pool using the IPDHCP pool command followed by the pool name. And last, we configure the specific tasks. Then network statement is used to define the range of available addresses. The command default router for the default gateway router. The DHCP version 4 protocol is enabled by default. To disable, type the command no service DHCP, and to re-enable, use the command service DHCP in the global configuration mode. For verification, when typing show running config command output displays the DHCP version 4 commands configured in router 1. The operation is verified using the show IP DHCP binding command, which displays a list of all IPv4 addresses to MAC addresses bindings. The show IP DHCP server statistics is used to verify the messages being received and sent. By the server, it also displays the account information regarding the number of messages. In the image, there are no bindings, and the statistics indicate no messages sent or received. There are also no requests. If the ipconfig hole is issued in PC1, it displays the TCP/IP parameters. Now, what is a DHCP relay? Well, it is a network where enterprise servers are located in a farm, which may provide DHCP, DNS, TFTP, and FTP services for the network. Clients in these networks are not usually on the same subnet as the servers. Clients often use broadcast messages to receive IPv4 addresses. Sometimes Soho and branch sites have to be configured as DHCP version 4 clients in a similar manner to client computers. To configure an Ethernet interface as a DHCP client, use the IP address DHCP interface configuration mode command. With the IP address DHCP command, the show IP interface command confirms that the interface is up and that the address was allocated by a DHCP version 4 server. This image shows the default WAN setup page for a router. The Internet connection type is set to automatic configuration, and the MAC address clone feature uses a specified address as a source MAC address on the ISP-facing interface of the router. DHCP version 4 problems can arise for a multitude of reasons. A systematic approach to troubleshooting is required as shown in the figure. To verify that the router configuration is correct, we should first check that the IP helper address command is configured on the correct interface. It must be present on the input interface on the LAN containing the DHCP version 4 client workstations and must be directed to the correct DHCP version 4 server. In second place, we should verify that the global configuration command, no service DHCP, has not been configured. This command disables all DHCP server and relay functionality on the router. As a troubleshooting task, verify that the router is receiving the DHCP version 4 request from the client. This involves configuring the ACL for debugging output. The image shows an extended ACL permitting only packets with UDP destination ports 67 and 68. The command debug IP packet is used to display only DHCP version 4 messages. Another useful command for troubleshooting DHCP version 4 cooperation is the debug IP DHCP server events command, which reports server events.
Similar to IPv4, IPv6 global unicast addresses can be configured in a dynamical way. There are only two ways that this can happen. The first one is the stateless address configuration, in which the device obtains his IPv global unicast addresses without the use of a server. To function, the client sends a router solicitation message to the routers by the multicast address, and then when the router receives the message, he responds with a router advertisement message in which they send the provide addressing information to the clients, and then the clients can configure his own IPv addresses. Finally, the message travels through the multicast address, and it returns to the client to start the address configuration. In this topology, we see PC1 is configured to obtain his IPv6 address in an automatically way. Since PC1 has not received an RA message, it sends an RS message to all the routers by the multicast address, and then he waits for a response. Then R1 receives the RS message, and he responds with an RA message. Included in the error message are the prefix and the prefix length of the network. This message is sent in a multicast address with a linked local address of the router as the source address. Then when PC1 receives the message that contains the prefix and the prefix length for the local network, PC1 will use this information to create his own IPv6 global unicast address. There are only two ways that PC1 can create his own unique ID that it used to create his IP address. The first one is the AUE64, that it used the AUE64 process using a 48-bit MAC address, and the randomly generated that use a 64-bit. This random number can be generated by a client operating system. Because this is a stateless process, before PC1 can use this new created IPv6 address, it must verify that it is unique in the network. So it sends a ICMP-v6 neighbor solicitation message with his own address as the target IPv6. If no one other device responds with a neighbor advertisement message, then the address is unique and the PC1 can use this new IPv6 address. There are three ways to configure and obtain an IPv6 address information automatically. By using the SLAAC process, and by using the DHCP-v6 process, or in a combination of both. This depends on the RF message. There are three options that a client receives from using these services, as it shows in the picture. However, it is important and recommended that all IPv6 devices perform a duplicated address detection on any unicast address, including the ones that are used with DHCP or SLAAC. Well, in the routers we have some flags that we can configure, and this shows the way the PC will obtain his prefix and his IP dynamically address. By default, Cisco has configured M flag equals to 0 and O flag equals to 0. This means that the array message will contain all the addressing information he needs to generate his own address, and there is no other information available from the DHCP server. So it will use his prefix, and it will generate his interface ID using AUE64 or a randomly generated value. We can configure manually these parameters in the command line. There is another method to configure the process. This is the stateless DHCP v6 option. This option informs the client to use the information of the array message from the router, but additional, he used the configuration parameters that are available in a DHCP v6 server. So using the prefix and the prefix length in the array message along with the AUE64 or a randomly generated ID, the client creates his own IPv6 address, but then the client communicates with a stateless DHCP v6 server to obtain additional information that is not provided in the array message. This process is known as stateless DHCP v6 because the server is not maintaining any client state information. It doesn't have a list or a table of the IPv addresses. It is only providing configuration parameters to the clients. To this configuration, the router advertisements flags are M flags equals 0 and O flag equals 1. Finally, we have the stateful DHCP v6. This option is the most similar to DHCP v4. In this case, the error message informs the client that it doesn't have to use the information in the error message. All the addressing information and configuration information must be provided by a DHCP v6 server. The DHCP v6 server will maintains the network and contains the tables and the information of all the devices in the network.